For our review, from the slides at least, what are some examples of clean water indicators? And you should be able to give at least 3. And a hint there could be focus on pollution-sensitive macroinvertebrates. So from the fish perspective, we've got darters, certain darters, dace, certain dace are good fish indicators, but then we've got those macroinvertebrates that we focused on even in the lab on the introductory day. So what are they? So we can think of hellgrammites or Dobson fly larvae, water penny beetle larvae, mayflies, stoneflies. Those are just a few examples. All right, what does sediment likely carry with it? So sediment can carry a lot of things with it, but from a pollution perspective, is sediment a problem? Yeah, it is, because it fills in habitats, but what else may sediment carry with it? And sediment may carry with it some bacteria that could also include the fecal indicator bacteria, and that may suggest that pathogens might be also getting carried with it. That's not entirely the case, but fecal indicator bacteria do get carried with sediment. And then nutrients, phosphorus and nitrogen, particularly phosphorus, can hitch a ride with that soil into the streams. All right, what are a couple entities involved in promoting BMPs, and what are BMPs? So BMPs are best management practices, which exist in a lot of fields. With respect to water and the environment, when we often hear of BMPs, we're often thinking of sediment or erosion control. And a couple entities involved in promoting BMPs in the United States now, currently we have the Natural Resources Conservation Service. So that's the NRCS, Natural Resources Conservation Service, and they often are co-located with the various state land-grant universities in the respective states. So in Kentucky, we've got the University of Kentucky and Kentucky State University that are our land grants. UK has county extension agents that serve all the counties of Kentucky. Ohio has Ohio State University. It's got a county extension agent that services every county in Ohio. So the extension service of the land-grant universities also help a lot with promoting best management practices. All right, what are BMPs? Again, that's best management practices. Name 4 BMPs that can be reduced or used to reduce soil erosion, and name a few ways to stop CSOs. So 4 BMPs that can be used to reduce soil erosion. One might be with regards to agriculture. We could engage in no-till agriculture. Another option in agriculture, and not just agriculture, anywhere where soil is exposed. Get cover crops down or cover it with something. So cover the soil, don't leave soil uncovered. So those are 2. Another common problem with soil erosion is stream bank destabilization. The banks of creeks will collapse sometimes, or banks of lakes will collapse. So let's get that stuff covered as well. So we could do stream bank stabilization through the addition of rock or gabion block or riprap or something like that. We can also plant trees on stream banks. So willow trees, or even a vegetation that we could get down like a vetch. It's not a tree, it's a pretty flowering plant. So those are some options. Another option to reduce soil erosion would be to prevent animals from tearing up the stream banks. Another option that could reduce soil erosion is whenever we've got roads, whether it be logging roads or trails, or they could be fire lines, to put in diversion ditches or diversion bars or water bars. Those are all kind of synonyms there. So the water doesn't flow down the slope, it breaks off here and there. All right, name a few ways to stop CSOs. So how could we stop combined sewer overflows? So there's a few videos that were out that we provided on that subject. One, relating to permeable pavers. So we could reduce the amount of runoff by having permeable pavers. We could encourage the use of more green spaces. We could reduce the amount of storm sewer water just going into the sewer systems. So reducing the amount of blacktop or asphalt, replacing it with green space. Those are just some things. All right, what are a couple reasons why mountain streams have a high dissolved oxygen? So the main reason is a mountainous stream will often have a greater gradient that is traveling down. The angle the stream is traveling down will be steeper, so it'll have more velocity and more speed. More speed means when it has turbulence, it'll have more ability to get aerated. So mountain streams have a lot more turbulence, riffles, and more aeration. Another reason is often mountain streams tend to be cooler because they may either be in really high altitudes, and in that case, the temperature helps a lot just by altitude. In other cases, in the east, a lot of our mountainous streams often are forested around them, so the shading will help keep the water temperatures cooler. So they may have less photosynthesis, but they are cooler and they have a lot of riffles. That allows them to have a higher DO. All right, what is the name of the list that the EPA requires that states provide to list the impaired streams? So the U.S. EPA, carrying out their charge as given to them from the Clean Water Act, says that states have to list the streams, rivers, lakes that are not meeting their designated uses. Those impaired streams end up on the 303D list. So the 303D list refers to the Clean Water Act, and it's a part of the Clean Water Act, so that's the list. And the process or approach or the rule that is used to get streams off the list. So if a stream's been deemed impaired, then it's ripe to have a TMDL study. Now, there's no money given by the federal government, or a limited amount of money by the federal government to help deal with this. But if a community or a watershed coordinator or team wants to help figure out how to get the impaired stream off the list, they can engage in a TMDL study, a total maximum daily load study. And the objective of the TMDL study is to identify how much pollution that stream can hold or withstand while still meeting its intended designated use. And then what steps can be put into place to help the stream, river, or lake get to that point, which could include various pollution controls, both non-point source and point source. So the TMDL is the name of the approach or rule used to help get streams delisted. True or false? Dilution is always the solution to pollution, and you should hopefully note that that is false. Dilution can sometimes help reduce the impact of pollution, but there are certain types of pollutants that you don't want to dilute with water. Organic pollutants in particular, things that bioaccumulate in nature. So dilution is not always the solution to pollution. That statement, dilution is always the solution to pollution, is false. All right, what company is spending a lot of money on cleaning up the Hudson River, and why? So in the Vice video on Toxic, Our Nation's Polluted Waters, whatever it was called, talked about GE and the Atlantic tomcod and PCBs and black mayonnaise. So the sediments of the Hudson River are constantly releasing little bits of PCBs, an organic compound, an organic waste product released in the Hudson River by GE, decades ago. And it's persisting, it's trapped in the fish species there, so GE's cleaning that up. What are the three zones of a waste plume in a river system? So we have those three zones. We kind of have the zone of degradation, or the zone of pollution. So that's kind of the first zone. Below that zone, we've got the zone of active decomposition. And then below that zone, we've got the zone of recovery. Above the pollution zone, it's kind of the stream as it was before the pollution occurred. So the zone of pollution, also known as the zone of degradation. Then 2, we have the zone of active decomposition, and then below that we have the zone of recovery. That's the pollution assimilation model. Which zone of those three pollution zones has the highest DO? And that one's a little harder. Just before or right where the pollution comes in, you might have some high DO before it really takes a hit. At the end of the recovery zone, you may have a higher DO. Above those, the clean water theoretically would have the highest. But that's not as important as this next question. Which zone has the lowest DO and the highest BOD? So this is the area that's the most intolerant for life and would appear to have the worst water quality. and that would be the zone of active decomposition. That's where the demand for oxygen is the highest, which also is associated with a low dissolved oxygen. So that's the zone of active decomposition. The process in which a lake fills in or builds up a lot of nutrients, what's the name of that? So the name of that process associated with lake filling in is eutrophication. Eutrophication. And the two primary nutrients that drive that process are phosphorus and nitrogen. In most of the United States, phosphorus is the limiting nutrient. There's already enough nitrogen, but it's phosphorus that may be the limiting factor. But there are exceptions. In some cases, nitrate or various nitrogen compounds are limiting. All right, so what are the three ways of assessing the trophic status of a lake? Well, the three most common ways of assessing the trophic status of a lake are to measure chlorophyll A, Secchi depth, and or total phosphorus. Those are the three most common ways. Those are the ways identified by Carlson in his trophic state index. What are the names of the various trophic states of a lake? So if you had to say that that lake is a blank trophic lake, what is it? What are the options? So for the clean, deep, cold lakes, we've got the oligotrophic lakes. We've got the lakes that are kind of in the middle, the mesotrophic lakes, not metatrophic, but mesotrophic. And then we have the eutrophic lakes. And then there's some, derivations from that. We've got the hyper-eutrophic lakes, and even beyond that you have dystrophic lakes. But really, oligotrophic, mesotrophic, and eutrophic are the three most commonly used terms. All right, I'm not going to emphasize what the Greek root word "eu" means. I'm not quite sold that it means self-feeding for trophic, eutrophic, but the trophic definitely refers to feeding, And is a eutrophic lake heading towards increased eutrophication, or is it heading towards, or if a eutrophic lake is heading towards increased eutrophication, we would consider that to be a positive or negative feedback mechanism. So typically it feeds upon itself, and it just makes itself worse and worse, depending upon if you want it to become a wetland, this is a good thing, but from a positive or negative feedback, as it becomes hypereutrophic, it speeds up the likelihood that it becomes even more hypereutrophic. That's a positive feedback mechanism. What are the three stratified layers of a lake? So we have the summer stratification that happens in temperate lakes in the United States. The top layer is the epilimnion. The middle layer is the metalimnion, also known as the thermocline, and the deep coldest layer is the hypolimnion. At what temperature is water the most dense? So when is water the heaviest? So it's 4 degrees Celsius or approximately 39 degrees Fahrenheit. And if you had to draw water from a lake for drinking water purposes, where would you draw it from? The hypolimnion, the metalimnion, the epilimnion, the middle of the epilimnion, the middle of the hypolimnion? Where would you draw it from? And I would suggest that we draw it from somewhere around the upper part of the hypolimnion, deep enough that we're outside the photic zone, but high enough off the bottom of the lake that we're not likely to pick up organic compounds or sediments. The next section for the course we'll get into for the drinking water section, so you may already have the slides, but we're not going to go into those. If you have any questions in preparing for your exam, feel free to reach out to me. Use the review guide, take the quizzes, use the practice quizzes, and I'll do my best to support you. Thank you.